Okay, I'm going to pick up here where the video left off since I'm not here today. Given this picture here, I'm going to erase this of what's here. One, if you're really confused today, maybe watch the videos from Patrick that I posted that are due tomorrow. You can watch that first if you want, or watch this and then watch it to get us to tomorrow. But it says, find the volume when the region is rotated about the line y equals -2. And so that's kind of what I did here, and there's a great video from Patrick that he does this a lot, but that's what I just had drawn here. But y equals -2 would be this line right here, y equals -2, and I want to rotate that, that shaded region around that line, right? So I'm still going to have pi. My bounds are still going to be from -1 to 2. But now that it's across the x-axis, it kind of changes things a little bit. But it's still going to be involved in our radius if we think about that. And so when I look at this, if I'm going from the outer radius, right? So the outer radius is starting at the end of my shape and going to the line I'm crossing. So my outer radius, or starting here and going there, however you want to think about it. I like to think about it going here down to here, maybe the other way around. It doesn't matter since you square it. And so on the last one, we had to do 4 minus that, but now we're like subtracting a -2. So because it's across the x-axis, it's changing that equation, right? And so what was my lines again? X plus 2. So this one would be like outer radius squared minus inner radius squared. So outer radius squared would be x plus 2 plus 2, because like minus a -2, like adding that distance. So the x plus 2 would be this part to the x-axis, but then I have to add that extra plus 2 right there, squared. That would be my outer radius squared, minus my inner radius squared would be just going up to the edge of that, right? So like starting from here and going up to the edge of that graph, or if you don't like that side, we could do it over here, like from here. And so that's going to be the bottom curve, but again, it's like plus 2. So I don't know if you want to do 2 plus or just plus 2 at the end, but that would be the curved one, which is x squared. So that would be x squared plus 2 squared. And then I really need my dx. Should really have an extra set of parentheses there. And again, I'm going to practice this with just the integration with the numbers, and then you can use your calculator as needed here. Don't forget your pi, okay? So outer radius squared minus inner radius squared. Again, there's some Patrick videos that can help us out here. So this is really like x plus 4 squared minus x squared plus 2 squared. And then I'm just going to FOIL that out. I think that's going to make life easier. So that's going to be x squared plus 8x plus 16 minus x to the 4th minus, because of this negative sign here, 4x squared minus 4. And then if you want to combine things and make life a little bit easier, I'm going to do that. I know you don't have this lovely extend button like I do, but I have negative x to the 4th. And then negative 3x squared plus 8x plus 12, because 16 minus 4. And then I'm going to integrate that, which I could do, right? So I have my pi. Then I have negative x to the 5th over 5 minus 3x cubed over 3. The 3's cancel. Plus 8x squared over 2, which is 4x squared. Plus 12x from -1 to 2. And if this was without a calculator, you would just plug your numbers in and leave it, right? So that would be negative 2 to the 5th, negative 32 over 5, minus 2 to the 3rd is 8, plus 4x squared, 4 squared, or 2 squared is 4 times 4 is 16, plus 12 times 2 is 24, minus, I'm going to do parentheses here, that's just going to become a 1/5, minus 1, plus 4, minus 12. And then that's where, if you have a calculator, then you could do that on the calculator with the fraction button. And if you do that all on your calculator, you should get 162 over 5. Or I would say the volume there is 162 pi over 5. And again, it just never hurts to touch up on our integration. Again, without a calculator, you wouldn't have to add it up. You could just leave it unsimplified, but that's the process there. So the other thing I want to look at really quick is what I talked about yesterday about in terms of y. So let's look at this one. It says if the axis of rotation is the y-axis or is parallel to the y-axis, the integrand needs to be in terms of y, and the limits of integration need to be y values. And that's because if you're rotating it about the y-axis, you're now going in a different direction, and that's going to change your bounds in terms of y. And so it says, consider the region pictured to the right that's bounded by the graph y equals plus or minus the square root of x, and y equals x minus 2. It says, find the volume when the region is rotated about the y-axis. So really important, we're now rotating it this way. So if you think about taking that shape and going around the y-axis, hopefully you can kind of think about, that's almost going to look like a bowl or like a spindle kind of shape. Spindle, do you even know what that means? But here's what's really important. We have to do this in terms of y now. So step 1 is if you're doing it in terms of y, your equations need to be in terms of y. So step 1 is I'm going to solve this for x. Normally we have y equals, but in terms of the y-axis, we want to solve it for x. So that just means I would square both sides and get x equals y squared, and that should make sense that that's the sideways parabola right here. And if I solve this for x, I'm just going to add 2, and I'm going to get x equals y plus 2. Y-axis means y equations and y bounds. And so if I'm finding the volume of the region, my bounds now are the y bounds here. So I'm still going to do pi. But now my bounds are -1 to 2. And my outer radius now is starting at the end of the shape and going to where I'm rotating it, right? So this is my outer radius, which is going to be this line squared. So that's going to be y plus 2 squared minus my inner radius would be from where I'm rotating it to just the edge of that shape, right? So that's going to be the curve. And that's going to be my y squared. So that's going to be minus y squared squared. And now because it's in terms of y, I'm going to do dy. Are you with me on that? Outer radius squared minus inner radius squared. And again, we can do some math here where we get y squared plus 4y plus 4 minus y to the 4th. So if I was going to integrate this, that would be y cubed over 3 plus 4y squared over 2, which would be 2y squared, plus 4y, not 9y, minus y to the 5th over 5 from -1 to 2. So that's going to be 8/3 plus 4 times 2 is 8 plus 8 minus 32/5 minus, I'm going to do parenthesis here, -1/3 plus 2 minus 4 plus 1/5. Check my math on that. And again, you could just use your calculator as well on this one, but you know, doesn't hurt to do this. And so if you use your calculator now to add all this up, you should get 72 pi fifths. But again, it's all about the setup. So maybe on the next one, let's just do the setup and not do the math. So this one says find the volume when the region is rotated about the line x equals 4. So again, I'm just going to erase again and start, only it's still y squared equals x, and x equals y plus 2. But now if I'm rotating about the line x equals 4, so anytime you rotate about the x-axis or any line parallel to the x-axis, you use x bounds. But when you rotate about the y-axis or any line parallel to the y-axis, like a vertical line, you have to use y bounds because you're rotating it in that direction. And so this is just like with the x stuff, except for you have to think about the shapes that are happening now in the y bounds. So again, don't forget the pi. My bounds haven't changed. My bounds are still -1 to 2. They're still the y bounds. But now think about outer radius and inner radius. So outer radius would be all the way to the edge of the shape, right? So starting here to the outside edge is going to be the curve now. But it's not just the y-axis. So I'm starting here. So it's going to be 4 minus y squared squared. Or if you say y squared minus 4, that works too, because when you square it, y squared minus 4 squared, that's going to be the same thing when you FOIL that out. And so it doesn't matter which way you do it. I feel like I do it like Patrick does it, and he starts with the 4, but maybe not. And so then the other one, if I do the inside, that would be starting here and going to the outside edge, the inside edge, I don't know, which would be the line. So that would be minus, and again, I'm going to say starting at 4 minus the line, which is y plus 2. But I'm going to distribute that negative and say 4 minus y minus 2, which would give me 2 minus y squared. But again, if I have a calculator, this is where you could just do Math 9 on your calculator. Don't forget your dy. And this is one, let's just say, let's use our calculator to do it, because I really care more about the setup. And you can check this, but you should get 108 pi over 5, I believe. I wonder if I just did a bunch of math that you already have done. I don't think so. Okay, last one. Find the volume when the region is rotated about the line x equals 7. So x equals 7 is just moving it this way, right? 6, 7. So what do you think it's going to look like when you set that up? Are my bounds changing? So you could think about extending this, extending this if you wanted. What's happening with my outer radius is it's just going more, and what's happening with my inner radius is it's going more. So hopefully you agree that it would be same y bounds, -1 to 2, but now my outer radius is starting at 7. So 7 minus y squared squared minus my inner radius would be 7 minus y minus 2, right? Because I'm subtracting all of it squared. And again, please watch the Patrick videos. That's the next thing that you're gonna do in here is watch those videos. Go ahead and work this out and see what you get, and see if you can do it without the calculator to FOIL it out and get the right answer. And I'll tell you the answer, but I won't bore you with me doing all the math. 243 pi over 5. And if you need help getting your calculator as a fraction, let me know. Math 1 changes the decimal to a fraction if you're struggling on that. Okay? So your Next assignment is to watch the 3 videos from Patrick that are posted on Edpuzzle, and then you can go ahead and get started if you still have time left on the next assignment, which is homework 62, and that's what we're going to work on tomorrow. Pay attention to whether it says find area or volume and how it's rotating, okay?